For my original design, I thought I wanted to do something with maybe like a cube or a pyramid, but as I built it, I ended up simplifying it down to just a triangle kind of laying down on its side with a spoon attached to it. To build my catapult, I used number 2 pencils, some small rubber bands, and a plastic spoon. This is what my catapult looked like in the end, and here's a video of me shooting the marble. Next, I took this video and put it in Capstone, where I was able to track the movements of my marble. In doing so, I was able to create 4 graphs: the position of the marble along the x-axis versus time, the position of the marble on the y-axis versus time, the velocity of the marble on the x-axis versus time, and the velocity of the marble on the y-axis versus time. Once I completed my video analysis, I was able to use the graphs to help me calculate initial velocity, which was required in order for me to calculate the range at which my marble had traveled and the maximum height my marble had reached through its flight. Then, also using the data from the graphs, I was able to calculate the initial acceleration of the marble, and using the mass of the marble and the initial acceleration, I was able to calculate the force that was exerted on the marble when launched. When I went back into Capstone, however, once I used the tools Capstone had to measure the range and height and compared them to my calculated values, it turns out that the Capstone values were close to about half of what I had calculated. When comparing these results, they're obviously not the same, and so I figured that the possible reasons for this could be like human error as to whether the ball was shot ideally. Like, it could also depend on like the camera angle, or if my scale was correct, or if my graphs were correct, and anything along those lines could affect how my data turns out. The main concept that this project covered was projectile motion, which we studied in class and did problems just like our catapult and marble, where a baseball was hit, a soccer ball was kicked, you threw something that would land at the same height as it was released. And by studying this, it helped us in this lab because we knew the equations for height and range and how to calculate what we needed.